Okay. Differential or difference equation representation for LTI system. Here, this is the another type of time domain representation for LTI system. From this, it gives the relationship between the input and the output of the LTI systems. When I'm going to take the differential equation is going to be used for the continuous time to represent the continuous time system, for whereas difference equation is going to be used to represent our discrete time system. When I'm going for differential means it is for the continuous time. When I'm going for difference means it is for the discrete time equation representation. Okay. In the same way, I mean, in the previous cases for continuous, we are going to take in the integration factor. But when you are going for discrete means it's a summation, right? In the same way here also. Then differential equation representation for continuous time LTI system. Differential equation is going to be taken as, here consider, the general form of the linear constant coefficient differential equation is going to be taken as summation k is equal to 0 to n ak, differentiate with the k only, right? Dk, here it is taken, divided by dtk of y of t is going to be equal to summation k is equal to 0 to m. So it's the summation bk differential d by dt of x of t. Okay, x of t is the input of the system, input to the system, and y of t is the output of the system. The integer capital N what we used is known as the order of the differential equation. Okay, then the expression for the output y of t, that is the solution what we will be getting. It is described in two components. The first one is taken as the natural response. What is this natural response? This is the output due to the initial conditions. The output what we are getting based on the initial conditions, and it is denoted as y power n. In bracket you have to write n of t, and this is also known as zero input response. Remember this. Natural response is also called as a zero input response. Next is about the forced response. The forced response, it is due to only the input, and it is going to be denoted as yf. Observe here, y in the power you have to write as f of t, and this is also known as zero state response. Don't confuse here. Zero input response means natural response. Zero state response means the forced response. The natural response is the system output with no inputs. A natural response means we are not going to provide any input. Initial conditions what it is kept, from that only the signal processing. Okay, that's what the meaning. Whereas the forced response is the system output for zero initial condition. Next, no input means it will be zero. In forced response means zero initial condition. You can differ when you are going to solve the problems. Okay. The first one if I take, that is the natural response, yn of t, zero input response. This is the output of the system, with the zero input. Output of the system with zero input. Therefore, the general form of a linear constant coefficient differential equation is going to be x of t is going to be equals to 0. Remember this point. For zero input response, x of t will be 0 only. Okay, therefore, summation k is equal to 0 to n ak d by dt of k yn of t is going to be 0, because natural function, for that reason instead of y of t you have to write as y power n of t. Okay, that is going to be 0. The differential equation with input equal to 0 is known as homogeneous equation. this, when input is going to be equal to 0, it's known as homogeneous equation. Okay. Next, the differential equation with input equal to 0 is known as homogeneous equation. Therefore, the natural response for a continuous time system is of the form, when it's going homogeneous equation is going to be taken as y n of t is going to be equal to summation I varying from 1 to n ci e power ri of t. Okay, where ri are the n roots of the characteristic equation. Ri is nothing but roots of the characteristic equation. N roots. It depends how many roots you will be getting. Okay. Therefore, summation k is equal to 0 to n of ak r power k is going to be equal to 0. Okay. If the root ri repeats m times, it repeats m times means, then we include m distinct terms in the natural response, that is taken as e power ri of t, comma, when it's repeated 2 times, then t into e raised to ri of t, then if it is repeating 3 times means t square e power ri of t is going on, then t raised to m minus 1 e raised to ri t. This is how you have to write. In the problems you will understand. Just remember how it is going for. Okay. Then the nature of the each term in the natural response depends on the roots of the characteristic equation. Roots of the characteristic equation, that is taken as ri. If ri is real, the natural response consists of a exponential terms. When our ri is of a real values, then imaginary roots results in sinusoidal terms, imaginary roots sinusoidal terms, and complex roots leads to the exponentially damped sinusoids. Observe here, when ri is of a real number, then it consists of the exponential terms only. Then if the roots are imaginary, then sinusoidal terms. When it is of complex, it is having real part and also of the imaginary part, then the roots leads to the exponentially damped sinusoid signal. Okay, just you remember this for the natural response. Now we'll solve the problems based on natural functions only. Okay, here the first problem it is given, that is find the natural response for the system described by the equation. Here the differential equation is given for us, that is 5 dy of t divided by dt plus 10 y of t is equal to 2 into x of t. When it is going to be y of 0 is going to be taken as 3. This is a condition they only given for us. Okay, then what they told, they only told that we have to find what is the natural response. This is very important. It will be asking for 6 to 8 marks. Okay, all the problems based on this topic. Okay, this is the given equation. First you write that when it is of a natural response, input x of t is going to be 0. Therefore 5 dy of t divided by dt plus 10 y of t is going to be equal to 0. To obtain characteristic equation, previously we came to know that dk of y of t divided by dt k, it's represented, it's taken as r of k, right? Differential equation is going to be taken as r. If it is of d square of y of t divided by dt means what you have to write, r power 2, means based on the power, based on the degree. Okay, what's given in this, it is only 1 only, means dy of t divided by dt is going to be taken as only r power 1 it will become, right? For that reason 5 into r plus, here we don't have any differential part, for that reason you have to take as 1 only. Therefore plus 10, that is going to be equal to 0. From this find the value for r, that is r is nothing but, after solving you will be getting as, it is easy calculation you can do of that, right? R is going to be taken as minus 2. Therefore the natural response yn of t, natural response we have to take as yn of t is equal to, what you have to consider, c, in the previous we taken here, that is ci e power ri of t. Now we have to take of that c, I means 1 only, because in this only one is there, right? Only one differential equation is there, only differential equation is there, only one term is there. For that reason that is going to be c e power r, this r, okay, ri of t, right? Ri e power ri of t, e raised to r of t. Therefore what is our r in this case? C e power minus 2 of t. Okay, then after that what is the condition here it is given, that is y of 0 is going to be equals to 3. Substitute y of 0 is equals to 3 for t is equals to 0. Then what you have to do, substitute t as 0 in this equation, okay, y of 0 is going to be equal to 3, y of 0 is nothing but in this 3, then t is going to be 0, c e power minus 2 0, what is given as 0 only, right? Therefore c is going, e power 0 is 1 only, therefore what will get, c is taken as 3. Okay, therefore natural response, if I substitute for 3 value, c value, therefore the natural response is going to be yn of t is going to be equal to 3 e power minus 2t. Substitute in this equation, you will be getting out. Okay, this is what you got for the natural response. This is the problem where our root is in a real one, right? Minus 2 only. Next we will solve for the next set of problem. Second problem is find zero input response of the system described by the differential equation. That is, differential equation is taken as d square y of t divided by dt square plus 3 into dy of t divided by dt plus 2 into y of t is equal to x of t plus d x of t divided by dt. The condition here it's given as dy of t Okay, in this problem y of 0 it's given as 0 and dy of t divided by dt it's given as, at t is equals to 0 it is given as 1. Okay, what you have to find, we have to find the natural response. Observe here the question what it is given, they not mentioned as natural response, they given as zero input response. That's what you have to remember. In the question paper what they asked, first you observe, then you go on solving. Okay, then natural response is the solution of the homogeneous equation. When you get homogeneous equation, when x of t is going to be equal to 0. Okay, means whole x of t is going to be, whole term is going to be 0 only. Therefore d square y of t divided by dt square plus 3 dy of t divided by dt, same thing, everything at the LHS it will be remain same, that is 2y of t is, that whole is going to be equal to 0. Then write the characteristic equation. Characteristic equation is nothing but means based on a differential, based on the power. Okay, therefore for this d square y of t dt square is, I can write as r square plus 3 into r plus 2, that is going to be equal to 0. Find the roots for this. After solving for the roots for this, what you will be getting, you will be getting as r1 is going to be equal to -1 and r2 is going to be equal to -2. Roots are real and real, the natural response. Therefore yn of t is going to be equal to, here two roots are there, for that reason c1 e raised to r1 of t plus c2 e power. To observe here, I is varying from 1 to n, it depends, c1 c2 c3 depends on how many roots you will be getting. Okay, here we got two roots, for that reason c1 c2 will get, and e power r1 of t and e power r2 of t will be getting. Then what is our r1 here, r1 is taken as -1, so e raised to minus t, and r2 is nothing but -2 t you will get. Then if I differentiate, this natural function, that is yn of t, why we have to differentiate? Because here you observe dy of t divided by dt is at t is going to be equal to 0, is equal to 1. Here it is given. If it is given, for differentiating terms means you have to differentiate natural function. Okay, d yn of t is going to be, if I differentiate e power minus t, I will getting as -1 only, -1 c1, this is a constant value, e power minus t. When I differentiate e power minus 2t means -2 c2 e raised to -2t you will be getting. Then put y of 0 is going to be equal to 0. Here it is given. Okay, it's given. Y of 0 is going to be equal to 0. dy of t divided by dt at t is going to be equals to 0. Therefore, this I can write in some of the books, they may give as y dash of 0 also. Y dash of 0 is nothing but dy of t divided by dt only. Don't get confused here. That is going to be equals to 1. Okay, then y of 0 is going to be equals to 0 means, for the natural function t is going to be 0, this whole function is going to be yn of t. If I substitute y of 0 is means 0 only you will get, e power r1 of t, t is, if I substitute as 0 means c1 you will get only, plus here also you will get as c2. That is taken as equation 1. Then substitute for this, in this condition you have to substitute to get this equation. You have to substitute in this. Then substitute dy of t divided by dt at t is equals to 0. What is the value? 1. When I substitute t is equals to 0 in this equation, it's given already, y dash of 0 is going to be 1, that is going to be equal to, when t is equal to 0, minus c1, then -2 c2. Only thing what you have to do, substitute t is equals to 0 in yn of t and also dyn of t divided by dt. Okay, then you will getting equation 1 and equation 2. Solve for equation 1 and 2. Here what I can write, c1 is going to be equal to minus c2, that you substitute in this equation. Okay, minus c2 will get minus of minus, it's going to be with 3, right? You solve for this, it is a simple calculation you can do of that. So you will be getting as c2 is going to be equal to -1, then c1 is going to be equal to 1. Then you substitute these two values, that is c1 and c2, in the natural response equation, that is yn of t. So after substituting, what you will get? The natural response is going to be equal to yn of t. C1 is going to be 1 only. So e raised to minus t minus of e raised to, here in this equation, right? That is minus 1 minus e raised to minus 2t. This is one type of problem where in the first problem the root what we got is of a real function. Here real roots, but it is repeated, real roots only. Minus 1 we got and minus 2 got, right? It's a real repeated, okay? Then two real roots actually, okay? Next problem, solve the following homogeneous equation, differential equation with the initial conditions specified. Here it is given as d square of y of t divided by dt square plus 2 into dy of t divided by dt plus y of t, that is going to be equal to 0. Here the condition is given as y of 0 is going to be 1, then y dash of 0 is going to be 1 only. First we have to do, we have to, here directly it's given homogeneous equation, no need of taking x of t is going to be 0 here. Directly you take the equation what is given, then find the roots of the characteristic equation. Therefore here it is also squaring, right? D square, for that reason r square plus 2 into r plus 1 is going to be equal to 0. After simplifying, you will be getting the roots as r1 is going to be equal to minus 1, r2 is going to be equal to minus 1, r1 r2 is going to be equal to minus 1. Okay, the roots are repeated. Here it is repeated. In the previous case, real root, two real roots we got. Okay, both the roots are real. Therefore the natural response is going to be, observe here, yn of t is going to be equal to c1 e power r1 of t plus c2, observe here t e raised to r2 of t, you will be getting here extra is coming t if it is real repeated roots. Okay, therefore that is going to be equal to, substitute for r1 and r2 here. See, after substitution of r1 and r2, we will be getting as c1 e power minus t plus c2 t into e raised to minus t. Taken this as equation 1. In the condition they given as y dash of 0 also, means differentiation. For that reason differentiate yn of t, natural function. D yn of t divided by dtn is going to be taken as, after differentiation you will be getting as minus c1 e power minus t plus c2, it's a differentiation of a into b. Okay, like that you have to do. c2 after differentiation you will be getting as minus t e power minus t plus e power minus t. This is taken as equation 2. Then substitute t is equals to 0 in the equation 1 and 2. Then substitute for y of 0 is 1 and y dash of 0 is going to be 1. If I substitute, then I will be getting as, when I substitute here 0, you will be getting as 1. 1 is going to be equal to c1, because when t is equal to 0, this whole function is going to be 0 only. Only you will get as c1 e power 0 is 1, for that reason c1 is going to be equal to 1 only. Then differentiating, y dash of 0 is 1, so 1 is equals to minus c1, substitute t is equal to 0, that's it. Here it will be 0, then you will be getting as e raised to minus t c2, so plus c2 you will get. Solve for this, it is a simple maths now. So you will be getting c1 is directly we got as 1 and c2 you will be getting as 2. Then what you have to do, just you substitute in the natural response, that is yn of t is going to be equal to e power, c1 is 1, for that reason e power minus t plus c2 is of 2, 2 into t e power minus t. c2 is of 2 into t e power minus t. This is one problem. Then the next problem, determine the natural response for the system described by the following difference equation. Here it is given as d square of y of t divided by dt square plus 4y of t is equal to 3 into dx of t divided by dt, with y of 0 is equal to minus 1, dy of t divided by dt at t is equals to 0 is going to be equal to 1. Here it is given for us. Then first you have to do, we have to write homogeneous equation. D square of y of t divided by dt square plus 4 y of t is going to be equal to 0. Therefore, characteristic equation is going to be taken as, what you have to do? Just based on this differential equation, you have to write. That is, here it is d square, for that reason r square plus 4, that is going to be equal to 0. R square is going to be equal to minus 4. Solve for this, we will be getting as r is going to be plus or minus j2. Therefore, r1 is taken as j2 and r2 is taken as minus j into 2. Since the roots are non-repeated and purely imaginary, the natural response is going to be, here it is taken as yn of t is going to be equal to c1. Observe here, plus or minus j2 is there, for that reason c1 cos 2t plus c2 sin 2t. Here the value is same. Remember, the value is same. Only varying is of plus or minus j. For that reason, non-repeated and purely imaginary, because only j term is there. For that reason, c1 cos 2t plus c2 sin 2t. When it is differentiated, dyn of t divided by dt, that is going to be equals to, cos differentiation is of sin, here 2 is there, minus 2 sin, c1 sin 2t plus 2 sin differentiation is of cos, right? 2 cos, c2 is there, c2 cos 2t, then put y of 0 is going to be equals to minus 1, then y dash of 0 is going to be equals to 1. It's given for us already. Therefore, just you substitute for 0 in both the equation, t as 0 in both the equation. So we will be getting as, when I substitute here, sin 0 is be 0, cos 0 is 1, right? So y of 0 is given as minus 1, so minus 1 is going to be equal to c1. Then when I substitute for here, t is going to be 0, then we will be getting as 2 into c2, because sin is going to be 0, both will be going to 0 only, right? Then substitute, we got c2 is going to be equals to 1 by 2, then c1 is going to be minus 1. Therefore, the natural response yn of t is going to be equal to, substitute for c1 c2, where you have to substitute, in this, here we have to substitute. Therefore, minus cos 2t plus 1 by 2 sin 2t you will get. Next problem, here it is, find the natural response for the system described by the differential equation d square y of t divided by dt square plus 2 into dy of t divided by dt plus 2 into y of t is going to be equal to dx of t divided by dt, with y of 0 is equal to 1, dy of t divided by dt at t is equal to 0 is going to be equal to 0 only. Therefore, first you have to do, we have to write the, what is homogeneous equation, that is d square y of t divided by dt square plus 2 dy of t divided by dt plus 2 y of t is going to be equal to 0. Therefore, characteristic equation is taken as, from this r square plus 2r plus 2 is going to be equal to 0. Finding the roots, use this equation, that is, root is going to be equals to minus b plus or minus square root of b square minus 4ac divided by 2a, the basic root equation. From that, if you solve, you will be getting as r is going to be equals to minus 1 plus or minus j1. Therefore, r1 is going to be minus 1 plus j1, r2 is going to be minus 1 minus j1. Okay, here roots are non-repeated and complex. The natural function is going to be taken here as, observe here, yn of t is going to be equals to e power minus t c1 cos 1 t plus c2 sin 1 t. Okay, this is the natural function you will be getting because all the roots are 1 only. Okay, then differentiate natural function yn of t, then we will be getting as dyn of t divided by dt is going to be equals to, if you differentiate you will be getting as e power minus t here minus c1 sin t plus c2 cos t, sin differentiation is of cos differentiation is of minus sin, minus e power minus t c1 cos t plus c2 sin t. I hope you will be knowing. First what you have to do, first you differentiate this whole, then keep this one as it is, then differentiate e raised to minus t, then keep this whole as it is. That is like a differentiation you have to do. Then what you have to do, put y of 0 is equals to 1, what's already given, this is given condition for us, right? Then y dash of 0 is going to be equal to 0. Therefore if I substitute for y of 0, that is in the natural function, I'll be getting as c1 is directly we got as 1. Then when I substitute in the t is equal to 0 in this differential equation, I'll be getting as, that is 0 is going to be equal to c2 minus c1. Therefore c1 is equal to c2, that is also equal to the 1 only. Therefore the natural response is going to be yn of t is going to be equal to, substitute for c1 c2 in the equation, so we'll be getting as e raised to minus t cos t plus sin t. These are all the problems based on the natural response. Okay, first what you have to do, the steps to solve this, first you have to write the homogeneous equation, then find the roots, based on the roots you have to write the natural response, then find out the constant values, that is c1 c2, if it is having c3 depends. Okay, from this you will got only of c1 c2. Okay, constant, find out your c1 c2 value, then substitute in the natural equation, you will be getting your result. Okay, we'll stop here.